Hello and welcome to my channel. Rhino here. Today I'm looking at the final video in Deflate's Basics of Intelligent Design series. Last time, he actually did a pretty good job of explaining why we know that evolution really is true, and then seemed to somehow be convinced that this was a good explanation as to why it is not. And while I haven't watched all the way through this one yet, it does seem to be headed in that same general direction. I'm actually going to be skipping over somewhat large chunks of the first half of this video, as he does a pretty decent job of explaining some evolutionary concepts. And for clarity, I will give my own summary of the same concept before getting into the nitty-gritty. So let's go! So first he starts off by explaining punctuated equilibrium, which basically is the idea that rather than being a very slow process, speciation can happen relatively quickly in short bursts that are separated by long periods of stability. One of the mistakes he makes in his description of it, though, is presenting it as a dichotomy. Evolution either happens slowly and gradually, or it happens in quick bursts with no evolutionary change in between.
Punctuated equilibrium rejects the idea that evolutionary change happens slowly and continuously, something that is absolutely fundamental to Darwinian and Neo-Darwinian theory. It argues the exact opposite instead, namely that evolution happens rapidly and only in certain limited periods of time.
See? That's close, but it's not quite right. There's nothing that I'm aware of in punctuated equilibrium that says that it can't happen gradually, and in reality, gradualism and punctuated equilibrium have kind of merged with each other. The idea behind punctuated equilibrium is that, while we do see species that are indicative of large transitions, the transitions of whales from land mammals, for instance, what we don't see are the transitions between these transitional species preserved in the fossil record. So if evolution always happens very slowly, then we should expect to see these transitions in a more granular form than we do. Creationists often like to portray this as Stephen Jay Gould admitting that there are no transitional forms in the fossil record, but that really depends on how granular we want to get with the transition, because there are definitely transitional forms in the fossil record, but that really depends on how granular we want to get with the definition of what counts as a transition.
Boldly defying the scientific status quo, Gould in a famous article claimed that Neo-Darwinism was effectively dead, despite its persistence as textbook orthodoxy, as he marched on to advance what he called a new and general theory of evolution.
Okay, let's look at the context of that quote. I don't trust that you left Neo-Darwinism out of the quotation marks. The full sentence is, "I have been reluctant to admit it, since beguiling is often forever, but if Mayer's characterization of the synthetic theory is accurate, then that theory, as a general proposition, is effectively dead, despite its persistence as textbook orthodoxy." So this isn't about Neo-Darwinism in general, it is specifically about Mayer's characterization of what is dubbed the synthetic theory, which I guess would be the modern synthesis, which is sometimes called Neo-Darwinism, but this is specific to what Mayer is saying here. So what is Mayer saying that is being responded to here? Well, just a bit earlier in the article, Gould quotes Mayer's description of synthetic theory. "The proponents of the synthetic theory maintain that all evolution is due to the accumulation of small genetic changes guided by natural selection, and that trans-specific evolution is nothing but an extrapolation and magnification of the events that take place within populations and species." Specifically, that description of evolution is what Gould here is saying is dead. And unless I'm misunderstanding the quote, I might be inclined to agree with Gould on this one, as I am unaware of anyone, whether they be a proponent of punctuated equilibrium or gradualism, who denies that large, fast changes can at least sometimes happen. Also, Jerry Coyne later said, "If Steve Gould's characterization of punctuated equilibrium involves the evolutionary mechanisms that he and Niles Eldredge proposed, then that theory, as a general proposition, is effectively dead, despite its persistence in Gould's writings." Coyne goes on to point out that punctuated equilibrium certainly exists as a pattern in the fossil record, but when you take a look at all the mechanisms that are proposed for punctuated equilibrium, they turn up somewhat lacking, while such a pattern is not outside of the expectation of the modern synthesis. It certainly did stimulate some areas of research, but apparently Gould had a habit of overstating his case.
So what made the two paleontologists go down such an unorthodox route? Gould and Eldredge were perfectly aware that Neo-Darwinism predicts the existence of an endless array of intermediate fossils.
See? Evolution predicts that this gradual spectrum would have existed in the organisms if you were to track them over time, but as the fossil record is an incomplete record, we would not necessarily expect to see such a spectrum in it. And on top of that, genetic changes that can lead to future evolutionary change can be morphologically invisible, giving the impression of stasis when genetic change is actually happening the whole time. And we know from modern experiments that apparently sudden large-scale changes can often have their basis in apparently neutral genetic mutations that happened well before the obvious large change. A good example of this being when E. coli developed the ability to metabolize citrate, which happened after more than 30,000 generations were bred in identical conditions. Because this experiment was periodically freezing samples of the E. coli as they went, they were able to take older populations out of storage and rerun the same experiment. By doing so, they determined that there was a genetic change that happened around the 20,000th generation that was integral to the development of the ability to metabolize citrate that happened 10,000 generations later. So evolutionary changes can be taking place for thousands of generations in a purely genetic form with no obvious outward changes. And even in this case, I don't think the ability to metabolize citrate would have been an obvious outward change either, though obviously what counts as an outward change is different in microbes than it is in macroorganisms. But the micro ones are a lot easier to study as they reproduce fast enough to give us a window into the evolutionary changes that would take too long to study in a population of more slowly reproducing macroorganisms.
Eldridge and Gould also observed what they called stasis. With this term, they captured the fact that all species, once they show up in the fossil record, either don't change at all during their geological history or only in ways far too small and insignificant for those changes to explain macroevolution or the origin of new species.
I mean, not quite. As I've discussed previously on this channel, I think the terms macro and microevolution should be retired, as all indicators point to the same evolutionary mechanisms being responsible for both. So in this case, what that would mean is that either a species shows up in the fossil record and remains unchanged until it disappears, or a species shows up in the fossil record and undergoes evolutionary change. Rephrased that way, I can agree that if you observe the fossils of a species over time, one of these two options will definitely happen, with the small changes being the more frequent occurrence. Now, I'm skipping ahead a bit as he does just give a decent explanation of allopatric speciation. Allopatric speciation is when speciation occurs through geographic isolation, where a small population of a species is isolated from the larger population, and so any mutations that occur in the smaller population have a greater chance of becoming fixed in the population than they would in the larger population, leading to more rapid evolution. Allopatric speciation is a real thing that happens, but where it runs into issues for punctuated equilibrium is that in order for punctuated equilibrium to show what we see in the fossil record, the new, smaller population subspecies would have to reintegrate with the larger population, but still be reproductively isolated from them, and for some reason just quickly replace the entire population. And that part is just something we don't see happen.
Let's now turn to species selection.
Sure. This is another aspect of punctuated equilibrium that doesn't really seem to happen in quite the way that Gould described. The idea is that natural selection applies to a species as a whole rather than to the individual members of that species. Not to say that it doesn't happen among individual members, but that the individual selection is less important to evolution than species selection. And species selection is a thing that happens. If you find two species sharing an environment competing for the same resources, the species that overall is better adapted to that environment will likely run the other one extinct. This is an example of species selection. But it cannot be the main driving force of evolution, because it can't explain how complex adaptations come about in the first place. In order to have a complex adaptation like, say, the jaw, there would have to be a massive process where multiple species that don't have quite the right jaw go extinct, leaving their sister species with a slightly better jaw still alive, thus paradoxically drawing out the process of evolution to take much longer than it actually takes. Which kind of flies in the face of the whole punctuated equilibrium idea.
The question we now turn to is, does this revolutionary hypothesis actually solve the problem of the missing fossils, as it purports to?
Kinda, but the missing fossils aren't really a problem to begin with, given both the spotty nature of the fossil record and the not necessarily morphology-based evolutionary changes that happen all the time.
Well, not really, and here are 3 reasons for that. The first key problem concerns the notion of species selection, which we've just discussed. Remember, species selection explains why some species tend to speciate more than others. Now, for the whole concept of species selection to make sense, you actually have to assume that a pool of different species already exists, upon which the mechanism of species selection can then act.
I mean, yeah, I'm not sure how this is a problem, though, unless you're going to insist that Gould never even considered the fact that at some point in the past there wouldn't have been a pool of species, which I highly doubt.
But this is exactly the problem. The 20 Cambrian phyla pop up suddenly in the fossil record, and the pool of species from which species selection could have picked those 20 animal forms is exactly what we don't have available in Precambrian strata.
Oh, you're back on that horse. Okay, well, ignoring all the problems with this that I brought up last time, let's just go with what you said. Did you hear yourself? There were 20 phyla in the Cambrian. Not 20 species, 20 phyla. Given that phylum is one of the highest levels on the taxonomy chart, and species is one of the lowest levels, having 20 phyla in the Cambrian means that there would have been a much larger pool of species that belonged to those 20 phyla, leaving plenty of room for species selection. Of course, you're wrong because of everything that Jackson and I both covered in videos 1 and 2 of this series respectively, and because species selection is not in fact the main driving force of evolution, but even if I grant that you're right, you're wrong.
Thus, all that species selection does is highlight the massive problem the Cambrian explosion poses for neo-Darwinism.
Okay, you really need to start thinking about what you're saying here. Remember, punctuated equilibrium was thought by Gould to be a replacement for neo-Darwinism, or the modern synthesis, whatever you want to call it. So to say that an aspect of punctuated equilibrium highlights a problem with neo-Darwinism is to agree with Gould's view on evolution. It does not serve to call evolution into question. It's important to keep in mind throughout this whole punctuated equilibrium versus gradualism debate that, no matter which side is correct, it's a debate about how evolution happens, not whether or not it happens. Also, the problem that you're pointing out isn't even a problem to begin with.
But it doesn't solve it, not even in the slightest.
No, you're right, it doesn't. What does solve it is what I laid out last time in video number 2.
This brings us to the second problem, which concerns allopatric speciation. It is certainly true that new traits have a higher chance of becoming fixed in smaller populations than they do in bigger ones. But there is an important flip side to that. Traits have to appear before they can become fixed, and the initial emergence of new traits is far less likely in smaller populations than in bigger ones.
Which is why often what you'll find with allopatric speciation is that the traits that develop that end up being the defining traits that separate the smaller population from the larger one are traits that already existed within the larger population in one form or another, but were not fixed in the population. When you look at a large population of organisms, particularly sexually reproducing organisms, most members of that population will have some traits that are not found in the majority of the population. If one of those traits somehow gives a survival advantage, but not enough of one to become fixed in a large population, then that trait will still exist in the population for a while, it just won't end up in all of the population. So isolate a small number of a large population, and there's a decent chance that they will already share a number of these non-fixed traits. These previously non-fixed traits will now have a much better shot at becoming fixed.
Yet new traits are a necessary prerequisite for evolutionary change.
Yeah. So a new trait develops in a population, part of that population becomes isolated, and some individuals in the isolated group carry that unfixed trait. And now it becomes a fixed trait in the smaller population. This isn't how it has to work, certainly, but this is one way that it can work.
Darwin himself pointed out that this numbers game is key when he said that forms existing in larger numbers will always have a better chance of presenting further favorable variations for natural selection to seize on than will the rarer forms which exist in lesser numbers.
Sure, the larger the population, the more potential for genetic diversity, which I would think would make it even more likely that speciation could occur once a small portion of that larger population is isolated, because there's already the potential for greater genetic diversity, and now with a sudden shrinking in the overall available gene pool, traits that would not otherwise have become fixed can now become fixed. You're doing that thing again, where you're explaining how evolution works and then pretending like it's a problem for evolution.
Gould recognized this dilemma, which is why he later adjusted his hypothesis by saying that while new traits may get fixed in short periods of time in smaller populations, the emergence of such traits happens among larger populations over the long periods of stasis.
There you go. Boom. Problem solved. Problem that wasn't even a problem to begin with solved.
But with this adjustment, punctuated equilibrium immediately ceases to be an explanation for the gap in the fossil record.
I mean, it doesn't. It still works as an explanation. But to the best of my knowledge, while aspects of punctuated equilibrium have certainly been incorporated into the modern synthesis, punctuated equilibrium as a standalone hypothesis has been somewhat less than successful.
Remember, the key point of the theory was this: evolution happens not gradually and slowly, but abruptly and rapidly, and among smaller populations.
I don't think it ever was a pure dichotomy like that. I don't think you would have gotten Gould to agree that evolution does not happen slowly. I think rather it was more that he thought the main driving force were these rapid punctuations. I might be wrong, I have only read a tiny portion of his very extensive writings on the subject, but that is my understanding of current evolutionary thinking. The reason that some species appear to be in stasis in the fossil record is not because they are not evolving, but because the majority of evolutionary changes are happening at levels that are not necessarily reflected in the parts of an organism that are most likely to be preserved as fossils.
And this explains why there are no intermediate forms in the fossil record.
No. Remember, it's not that there are no intermediate forms, it's about how granular you want to get with these intermediate forms, and whether or not you should see members of what are obviously the same species noticeably change depending on what time period they are in. But also keep in mind that it is possible that such variation did exist, and that it occurred within individuals that, based on the morphology of their bones alone, would be classified as a different species, but if we were able to examine their genetics, we would call them the same species. Because sometimes morphology can vary wildly across one single species. Canis familiaris is a great example of that. Had modern dogs existed in their current forms, but millions of years ago and been extinct today, it's quite possible that paleontologists would classify the different breeds of dog as different species of closely related animals, even though we know that genetically they are the same species. There are a lot of reasons why we might not see such small-scale changes in the fossil record, none of which actually result in casting any doubt on the theory of evolution as a whole.
This seems to require too much evolutionary change too quickly. But think about it. If new traits are actually generated in large populations and not rapidly but during the long periods of stasis, as the adjusted theory of punctuated equilibrium admits, then we have every reason to expect the existence of intermediate forms in the fossil record.
It depends entirely on what kind of changes these gradual changes are, and it depends on how persistent they were in the population. If they were more common, we might find some. If they were more rare, we would expect to find fewer of them. Remember, only a tiny percentage of the individuals of any given species were actually fossilized, and only a tiny percentage of the species to have ever existed would be represented in the fossil record, so there's a lot of reason to expect the fossil record to be a lot more spotty than it actually appears to be.
I mean, this is the very issue that gave rise to Gould and Eldridge's original theory of punctuated equilibrium.
Well, to hear Jerry Coyne tell it, Gould and Eldridge gave rise to their theory to solve a non-existent problem, so take that as you will.
This gets us to the third problem plaguing punctuated equilibrium. Both mechanisms, allopatric speciation and species selection, are limited in that they can only explain the selection upon traits and species that already exist, but they cannot explain the origin of complex traits of the higher taxonomic groups.
I feel like I have to explain this every time I deal with creationists, because they'd love to completely ignore this. Selection, whether it be just the general category of natural selection or a specific variant, selects for or against features out of a pool of features that already exist. There are other mechanisms that provide these features, like mutation, recombination, genetic drift, etc. Nobody is claiming that selection processes create new features, just that it selects for the features that exist that are most beneficial. So, no, Lucas, your observation that these traits have to come from somewhere is completely irrelevant to the discussion. As to them being provided by allopatric speciation, speciation is a description of the process by which new species develop, which means that you could consider the mechanisms that provide the new traits or features to be a part of it, meaning that allopatric speciation, when looked at broadly enough, does indeed include mechanisms for new features. I mean, you can also separate them out if you really want to, but they are closely linked together, even if they aren't the same thing.
Generally speaking, the lower you go on the taxonomic hierarchy, the less complex the traits are by which you distinguish between the different categories. Vice versa, the higher up you move on the taxonomic ladder, Generally, the more complex the traits are by which groups are distinguished from one another.
I see what you're going for here, but I'm not entirely sure I agree. It's not so much about complexity, it's more about specialization. For reference, he went through a long-winded example where he explained that the differences between two species of dragonfly are pretty small, but the difference between any given member of the arthropod phylum and any given member of the chordate phylum will be much more significant. But that's largely an artifact of when we are studying these creatures. This is hundreds of millions of years after the arthropod lineage split from the chordate lineage. If we go back to the Cambrian just after the split, then we find the differences to be much less significant. For instance, the delightfully named Unanozoon is a species that lived in the Middle Cambrian and is possibly the earliest example of a hemichordate. That is, it possesses some of the features that define the chordates, but it's also missing some, and as such, its placement is ambiguous. Emanaspis cambrensis is even worse, having at various stages been placed among the grappolites, chordates, arthropods, and frond-like organisms. These are categories that, for the ones that survived into modernity, it would be unthinkable to confuse, because the differences are just so stark. Because the differences between categories get cumulatively larger as time progresses, in a pattern that is perfectly predicted by evolution. So really what's happening here is not so much that the traits that distinguish a chordate from an arthropod are more complex than those that distinguish individual species, it's that younger traits that distinguish organisms from each other tend to be less significant than older traits.
However, allopatric speciation and species selection cannot explain the emergence of the higher-level complexities that mark entire classes, orders, and families.
Okay, well, let's forget about species selection, as that's not generally accepted as one of the primary mechanisms of evolution. Allopatric speciation, in combination with the mechanisms that give us new traits, would not be sufficient today to explain an isolated population of one modern genus evolving into a separate modern genus, which seems to be what he's going for here. He gives 10 examples of species of sea eagle being accounted for, but not all the other genuses of birds. But that is imposing modern diversity onto a past when there was less diversity. Maybe diversity is the wrong word, specialization might be better, but this isn't what we would expect to see in any scenario.
In other words, allopatric speciation and species selection cannot account for the emergence of the more complex traits that allow us to define and differentiate between the higher taxonomic categories.
Yep, I agree. Those two things by themselves cannot account for complex traits, which is one of the reasons why those two things by themselves are generally not thought to be the main driving forces of evolution. There's a whole slew of other processes at work that are more than capable of accounting for the complex traits.
This is why Richard Dawkins said that what I mainly want a theory of evolution to do is explain complex, well-designed mechanisms like hearts, hands, eyes, and echolocation. Nobody, not even the most ardent species selectionist, thinks that species selection can do this.
Yeah, kind of sounds like he's making the same point that I'm making here.
Now, you might be surprised to hear, or maybe not, that at some point even Gould himself admitted this problem.
I mean, you'd think the main proponent of that idea would have to have admitted such a problem in order for the Dawkins quote to have happened in the first place. Gould is probably exactly who Dawkins was referring to there.
What was his way out? He returned back, yet again, to good old neo-Darwinian orthodoxy. In the Structure of Evolutionary Theory, which was published in the year of his death, he conceded, "I recognize that we know no mechanism for the origin of such organismal features other than conventional natural selection at the organismic level."
In other words, he recognized that punctuated equilibrium, species selection, and all the other mechanisms that he had proposed do not operate in a vacuum, instead working with the other well-understood evolutionary mechanisms as well. Great! So what was your point in making this video? I mean, so far it's basically been a very drawn-out, Gould proposed an idea that wouldn't work on its own, and everyone knows that it wouldn't work on its own, so nobody's actually saying that it worked on its own, and that's why it can't work on its own.
And so, while Gould and Eldredge initially started out to challenge neo-Darwinism head-on with their rejection of a slow, gradual mode of evolution, Gould eventually turned around later, trying to sync his theorizing again with the classical standards of neo-Darwinism, as he recognized that punctuated equilibrium simply doesn't hold up.
Okay, so the worst-case scenario for evolution here, if everything you have said were 100% correct thus far, What we end up with is Gould thought he was revolutionizing the study of evolution, but instead wound up contributing some important ideas, but without shaking the foundation like he thought he was. I fail to see the problem here.
This now means that the conundrum of the fossil record, which plagues neo-Darwinism, has still not been solved.
Not really. I mean, I guess you could say that the conundrum hasn't been solved and that it never really existed in the first place. The conundrum of the fossil record is not a conundrum for evolution. There is plenty of evidence supporting evolution that has nothing to do with fossils. If you take away the entire fossil record, evolution still stands as the explanation for the diversity of life. Now, are there some unanswered questions about the fossil record? Sure. But given how much non-fossil evidence there is for evolution, these questions are not sufficient to call the theory as a whole into question. And in most cases, they don't even present a problem for evolution in the first place, like your missing Proto-Cambrian forms that should have been found in the Ediacaran. First, several have been found, but second and more important, a missing fossil that would fill in an evolutionary gap is not necessary in order for evolution to be true. Given how rare it is for an organism to be preserved, gaps are expected, and the farther back in time you go, the more gaps you would expect to find as more time has passed in which the organisms that actually were preserved could be destroyed. That's it for this one. That series wasn't really the basics of intelligent design, it was more of a we don't know some things about the fossil record, therefore evolution is false series. Today's comment of the day comes to us from Church of Chris, who says, "What's with the piano track in the background?" This was on my Matt Powell video from Monday, and to answer, the original video had heavy music playing all through it. I ran it through an AI noise removal tool in order to get rid of the music, but as good as that tool is, it's not perfect, so you can still hear the occasional piano note. I'm making a point of doing this with any video that has background music now, as Answers in Genesis has started using their background music to find response videos and claim the income from them under YouTube's copyright thing. So now I just remove any music in order to avoid such shenanigans in the future. Thanks for watching. Special thanks as always to my patrons, iOS Tilt Bill Gamer, Bryn Pound, Clench Eastwood, Lynn Dobbs, Mark McManus, Mark Hetcham, and all the rest, who are the allopatric speciation to the punctuated equilibrium that is my channel. If you'd like to work pretty well within the confines of the modern view of evolution, you can join us on Patreon for as little as $1 per week over at patreon.com/ViceRhino. If you feel so inclined, you can also support the channel through direct donation or my Amazon wishlist. Links to social media, all the ways to support the channel, and to my other projects can be found at links.vicerhino.com. If for whatever reason you want to send me stuff, my P.O. Box address is in the description. See you next time! Because the differences between the categories get cumulatively